Hello, this is Dr. Janes, and today we're going to talk about, this is the Parallax Boe-Bot with the tank tread modification added to it. And it's also got, it's run by an Arduino Uno. I don't know if you can see it, the Arduino Uno is actually under here. We'll zoom in on this guy. Okay. So here, the Arduino Uno is actually kind of fastened underneath, and it connects through the expansion port pins, and you can program this Arduino through the USB. Let's get we'll get a regular Arduino so you can see what they look like. So here's what an Arduino Uno looks like. They sell Micro Center or online or whatever for about $15. You can program them, plug them in through USB into your computer, and it provides the power. And there's a little PIC processor right here. You can actually program these and put them in separate things, but I like them. I like the Arduino in this case because it's got the analog to digital and digital to analog converters. Actually, the analog output is actually pulse width modulated waveform, so it's not true analog output, but close enough. And you can use that to control. If you can see here, see we have servo motors here, and these are variable speed servo motors, and they are controlled by the pulse width modulation output of the Arduino. The bigger the pulse width, the faster it turns. Okay, and so we will take a look at running. I've written a simple little program. It's a good starter program where I'm just going to tell the tank robot to exercise the servos in different ways, run forward and backwards at different speeds, and it's just pre-programmed based on how much time and how fast you have the servos going as to how far it goes in different directions. So let's take a look. Okay, so after you've programmed the Arduino through the serial port, we can there's some batteries underneath it here, and it takes five AA's, and this is the power to that guy. And actually these switches have to be set up properly. It's set up in position 2 right here. I don't know if you can see that. But that one's set in position 2, and then there's a reset, so you can reset the program if you want without unplugging it. But we are just going to plug it in, and we wrote the program that told it to do a series of different maneuvers, and we'll just let it go through that. So this is one tank tread going forward, the other one going backwards. Now they're both going forward. Now they're both going backwards. Now we're going forward again. Now we're going to turn. Okay. And this is all done just pre-programmed sequence of steps. Now the way we're doing this one is one tank tread's going slightly faster than the other one, so it's doing an arc, more of an arc turn. And we'll take a look at the program next. Okay, so now I'm going to talk a little bit about the programming that I just wanted to write a simple program that test out the servos and test out the action of the tank treads to make sure everything's working okay. And basically this program is just a whole sequence of commands. I'm going to tell you to do this, and then do that for a certain amount of time, and then that, and then just end afterwards. Okay, so here's a little information about the Servo Library. It's a library in Arduino that you can load up to control the servos, and it basically takes the place of the analog write function and disables it. So here is our Arduino IDE, which is running, and we'll start out, we'll go through line by line of the program, and the first line is loading up the Servo Library. Include servo.h, so this creates the library, or brings it into your program that you're writing here. And this is all written in processing. Now, actually, let me just go through the main structure of the program. So we have kind of a initial setup up here, and then we have a official void setup. So this is all the stuff you want to do just one time in the program, and it started with an open parentheses, and then it's ended with a closed parentheses. And so this is executed one time at the beginning of your process to set up everything. And then there's another main part of the Arduino program called a void loop, where if you want something to repeat over and over again, this is basically a loop that just runs over and over again. So since we just want to have it run through a series of commands and stop, I'm going to put all those commands in the setup. So we're going to set up the library, including a library. Then we'll create some objects. We'll create a servo left and servo right, and then we can attach different things to them to give them properties, make them do things. So this is the left and right servos of the tank treads. And then so we'll start up the setup. So we're going to run through this once. And so we're going to create servo left, and we're going to attach pin 13. Now that's actually hardwired inside of the Boe-Bot tank robot. And so the left one is hardwired to pin 13, and the right one is hardwired to pin 12. And if you take a look at, see, you have the Arduino here, and it's connected to all these pins. And so if you look up here, pin 12 and 13 are right here, and those are hardwired to the servos on the left and right hand side of the tank. And so we're going to tell that to the Arduino in the program that you're going to command these pins 12 and 13 to control the different servos. Okay, so here these are the pin outs of the Arduino. They're fed up through these feed through bars, and up here at the top, I don't know if you can see 13 and 12. So they count 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. 1 and 0 are actually serial inputs that the device uses to take commands from the USB and program the device. So they have, you can't use them for other things when you're using it for that. And there's more pins over here. Some of them are power, 5 volts, 3.3 volts. And these are the analog input, and these are the digital and pulse width modulation outputs on this side. Okay. And so then we'll go down here and we're going to start writing commands to it. So servo left, we're going to write microsecond. Now what this is doing, this is creating a pulse width wave that comes out, and depending on the width of that wave, it's going to either make the servos go forward or backwards, or it's going to make them stop. Now 15 is in the center, so see when we're writing this command right here, it says stay still, stay still. So this first command, we're making both of the servos go clockwise. Now since they're on opposite sides of the tank, when the servo, left servo and right servo are going clockwise, it's going to make the tank rotate because they're different handedness. And so we're going to make it rotate one way, and then we go down to the next line. 1700 and 1700 is going to make them rotate counterclockwise, so the tank is going to rotate the other way. 1500 is going to make the tank stop, and then 1300 is going to make it go forward, because one's spinning one way, one's spinning the other way. Okay. So we're just doing a sequence of commands. We're going to tell the servos to rotate in a certain direction, then we have a delay, so we're just going to delay it for a certain amount of time. So this is a timed program. It's not sensing anything or anything. We're just exercising the servos to see how they work. And so we give it a command, delay. This is 3 seconds. It's 3,000 milliseconds. And so then we'll give it another command, and then we'll wait, let it run for a certain amount of time. So if you want it to turn more, you would let this be a bigger number. You'd let it wait for a longer time before it executes the next command. Okay, so see this move forward, and then we have it stop for a second, and we have it move backwards and stop. And so we're just executing these different commands. Now, if you want it to move, the number that you put in here is a pulse width modulation waveform, so it gets bigger or smaller, so it has a higher duty cycle or less of a duty cycle, and the servos perceive that as to how fast they should rotate and which direction. So as I go down here a little bit more, I actually do like okay, 1450. So here's an intermediate one where one servo is moving not full speed, but some, kind of slow, and the other one's moving faster, so it will cause the tank, instead of rotating around a pivot point, which would happen if you just had one fixed and one moving. Since this one's moving slow and that one's moving faster, it will kind of move in an arc. So we're testing how the tank moves in all these different configurations. And so you can have the servos move at different speeds to create different trajectories of the tank. And so it runs through this set of programs, or set of commands. And then since this is only in the setup, this is in the setup void setup, it runs through it once and then it ends. And since I have nothing in the loop, it goes down into the loop and it just runs nothing forever. Now eventually I'll be writing some other programs for this guy where it will maybe sense something and react to it and just keep on doing the same thing over and over again, and we would put that into the void loop instead. Okay, so I think that's all I wanted to say about this right now, and well, I'll show you how to download the files into the Boe-Bot. Okay, so here we have a normal USB cable, which is the only USB cables they used to have, but now they got all the devices with the micro USB or whatever. So this is the A and B connectors, and this is what the Boe-Bot takes. And so we need to plug one end of the USB into our computer USB. And we will plug the other end into the Arduino input here. And we do have to disable, there's a little switch up here so we can disable the servos so it doesn't start doing crazy stuff, because it's actually going to power up the Arduino as soon as we plug this in, because it's going to be getting power from the computer. So I don't know if you can see under there, but all the lights on the Arduino are lighted up, and we are ready to execute commands from the Arduino. Okay, so we have our TankBot Arduino robot plugged into our USB, and we have our program all written here. And so what we're going to do is we're going to first we're going to check, go over to Tools, Board. We want to make sure this is an Arduino Uno, because all these are programmed differently. So this is set up, and you may have to set up the serial port also to the proper one. This one's already set up to this is the only serial port that it sees right now. Okay, so those two things have to be set up before you can upload your program into your device here, your TankBot device. Okay, and so now we can always check the program to make sure that it's written properly, make sure there's no bugs or inconsistencies, improper syntax or whatever. Okay, and so it seems to think that everything's okay. So now we can hit upload, and this I don't know if you can see it, when it's uploading, the lights on the Uno will blink,
and then when it finishes it will say done uploading, and it'll tell you how many bytes were uploaded to the sketch, and we should be good to go. This is Dr. Janes. Thanks for watching, and if people are interested in this, I will write more programs and hook up some hardware to this device, and we'll do some interesting things. So give me some good feedback. Good programming. I'll talk to you later. Bye.